I'm going to show you how to do AQA A-Level Maths Paper 2 June 2018 question 8. My name is Sunil Tanna. I'm a tutor and author. I live in Buckinghamshire, England. I'm available for one-to-one tuition both in person if you live locally and online. Determine a sequence of transformations which maps the graph of y equals sine x onto the graph of y equals root 3 sine x minus 3 cos x plus 4 and fully justify your answer. Okay, if you look at the final expression for y equals root 3 sine x minus 3 cos x plus 4, hopefully it will occur to you that you should be able to use an addition angle formula to get from sine x to that. So if we were to think about r times sine x plus alpha, it would be r times, and then let's use the addition angle formula on sine x plus alpha. It would be sine x cos alpha plus cos x sine alpha. And if we go another step, first of all we can expand the brackets, and since r is a constant and cos alpha is a constant, we'll put the cos alpha and the sine alpha first in each part of the expression. So we could write this as r cos alpha times sine x plus r sine alpha times cos x. And remember, this first part here and the first part here are constants. So we know that r cos alpha has to be minus 3. And we also know that r sine alpha is equal to root 3. So r sine alpha divided by r cos alpha is, the r's cancel out, is tan alpha. So tan alpha is root 3 over minus 3. And we can do an inverse tan on that to give us the value of alpha, which will be alpha is minus pi over 3 radians. We can also use Pythagoras to find the value of r. We can say that r squared is root 3 squared plus minus 3 squared, which gives us r squared is equal to 12, which gives us r is root 12, which can also be written as 2 root 3. Okay, and now we are able to rewrite our expression, or at least the first part of the expression, in this way. So you can see that root 3 sine x minus 3 cos x is, we can use a triple equal sign. The identity is identical to 2 root 3 sine x plus alpha, where alpha is equal to minus pi over 3, and therefore y is equal to 2 root 3 sine x plus alpha plus 4, where alpha is equal to minus pi over 3. So now we can think about what kind of transformations would be needed to get from sine x to this expression. Well, first of all, we have an inside of the sine, which is a transformation in the x direction, and when it's inside, it's always the opposite. So in the x direction is the opposite. So you would think instead of being plus alpha, we minus alpha. So we have a translation of instead of being minus pi over 3, plus pi over 3 and 0. Now in the y direction we've got two transformations. First of all, we scale the size of the sine curve up by multiplying it by 2 over 3. We stretch it. So a stretch in y direction, scale factor 2 root 3. And finally we have this translation to deal with the plus 4. So we translate 0 across and 4 up. And that completes part A of the question. Part B of the question continues. Show that the least value of this expression is equal to the expression that's given on the right. Now, if you look carefully, the bottom of the first fraction is the same as the value of y. So we can say that 1 over root 3 sine x minus 3 cos x plus 4 is the same as the expression that we had in the previous part of the question. It's the same as 1 over r, which was 2 root 3 sine x plus alpha. If you remember, alpha was minus pi over 3. Yeah? And then, of course, plus 4. Okay, so those are the same expressions. Now, the least value will be when the bottom of that fraction is the largest value. So the minimum is when the bottom is largest, and the largest value, which is when sine is equal to 1. When sine x minus pi over 3 is equal to 1, then we have the largest value on the bottom. So that will be 1 over 2 root 3 times 1 plus 4. Now all we need to do is do a little bit of tidying up to get our final expression. So what we're going to do is multiply the top and bottom of that by the 2 root 3 minus 4 and 2 root 3 minus 4, and then this will be rationalising the denominator here. So what we'll get on the top now is 2 root 3 minus 4. 2 root 3 times 2 root 3 is 12. We get plus 4 times 2 root 3 and minus 4 times 2 root 3, which cancel out, and then minus 16. So the bottom is divided by minus 4. So if we divide by, we could write this as 4 on the bottom and change the signs on the top. It will be 4 plus, it will be 4 minus 2 root 3 divided by 4. And if we divide top and bottom by 2, we're going to get 2 minus root 3 divided by 2, which is our final answer. Now, we can use the same idea to find the maximum value for part 2, which is find the greatest value of the same expression. So here, the maximum is when bottom is smallest, which is when sine pi over x minus pi over 3 is equal to minus 1. So if we place this into the original expression, we're going to have 1 over, and then remember we're using this expression here, so it'll be minus 2 root 3 plus 4. And just like before, we are going to rationalise the denominator. So we're going to times top and bottom by plus 2 root 3 plus 4 and plus 2 root 3 plus 4. This now becomes, on the top, 1 times that. I'll write it the other way around. 4 plus 2 root 3. We have a minus 12 and a plus 16, which will give us 4 plus 2 root 3 divided by 4. And then again, if we divide top and bottom by 2, we'll get 2 plus root 3 over 2. And that completes question 8.